there's a couple of buzzwords they like to use for combinations. Committee is one of them. If you see a committee, if you see a team, if you see a group, of sometimes a pair, whatever, they'll say it that way. A team, a set, something that doesn't specify order. If anything has order, it's a permutation. No order, it's a combination. Now be careful, because a lot of times they use the word different ways in both of these. They want different combinations, of course. So they'll use the word different ways. So keep an eye on the wording for this. So today we're going to take a look at all your combinations. They work a little bit differently, which is why I like to keep them separated. And again, here's their formula. So we just did C32. They say do this. This is my N, this is my R. 3 factorial over N minus R, 3 minus 2, 1 factorial, 1 factorial times R, 2 factorial. Well, this is just canceled out already. So this is 3 times 2 times 1 over 2 times 1. So it turns out to be 3. The easier way than this piece down here is to just set out your pieces, 3 times 2 over this factorial, 2 times 1. Okay. And it works the same way. The reason you want to do this is because you can visualize that formula in your head. So if I say 10 things 2 at a time, instead of having to put this in your calculator, what do you visualize? 10 times what? 2 positions. 10 times 9 divided by what? 2. What is 10 divided by 2? 5. What is 9 times 5? 45. So you can kind of calculate them a little bit quicker on your combinations if you think it out this way rather than their way. I find theirs has an extra step. All right. And it's interesting, too. I went to this, so that was my story about my summer. No one ever asked me to write an essay about my best thing in the summer, so I just wanted to fill you in. That was my best thing ever. Okay, so now let's try this. A State Department of Transportation. What page are 167? What did you say, Will? 171. Okay. I don't think these have any charts. All right, so let's take a look at this. A State Department of Transportation plans to develop a new section of interstate highway and receive 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the bidding companies? So different combinations. They told you right there, combinations. How many do you have to choose from? 16. How many do you want?
4.
4. So 16 combinations, 4 at a time. This is what you're looking for. This will give you more or less than if we did 16 P4.
I think it might be less.
Less. Less because order doesn't matter. I can get rid of all the same groups regardless of their order. So if I want to do this, I do 16 times 15 times 14 times 13 over 4 times 3 times 2 times 1. It's nice because you can, if you don't have a calculator handy, you can kind of work this out a little bit. I mean, those still you might have to multiply, or you can put this in your calculator. 16, go to math, go to probability, go to the NCR, plug that in, and then put in a 4. Okay? You got to put the 16 in first, just like the permutations. So you'll see that these are far less ways to do this. These are different combinations. Again, we're doing ways, not probabilities. Probabilities would make this into a fraction, and this would be your denominator. So we're going to get to the probabilities towards the end of this. Okay, you try this. The manager of an accounting department wants to form a 3-person advisory committee from 12 employees in the department. how many ways can the manager form this committee? There's the word committee. Committees, does order matter which way you sit on a committee?
No.
No. Unless you want to be the head person? No. So a committee usually is a group. So work this out. And come up with a number for me.
I don't know where I'm going with this.
All by yourself?
Yeah.
Okay, so what'd you come up with?
140.
Okay, and how'd you get that, Jonathan?
I did 20 NCR 3.
Okay, he put it in his calculator, 20 C3, and you got
1,140.
1,140. Let's put in 20 P3. Let's just see how many more possibilities we would have had if order mattered.
6,840.
A lot more, isn't it? A lot more. Because you have different combinations within each group that you have. Okay, so now we're going to start talking probabilities. Now we're going to start talking probabilities. We're going to use your permutations, use your combinations, and we're going to talk probabilities. A student advisory board consists of 17 members. 3 members serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve in any one of the positions. What is the probability of selecting at random the exact 3 members who hold those 3 positions? So pull this sentence aside. I want to know first, how many ways can I select a chair, a secretary, and a webmaster? Am I going to use permutations or combinations? Permutations, because why?
Order matters.
Order matters. Very good, John. Order matters. You know, I would write this down, guys, because this is really important that you get this. So, this is where your P comes in. How many members do I have to choose from? How many do I want for these positions?
3.
Okay, so plug this in your calculator first. 4,080. So 4,080 different arrangements of these 3 people being chair, secretary, and webmaster. There's only one way that they're already in there, isn't it? There's only one pair, one triple piece in there. So to find the probability of selecting those all 3 that are already there, there's only one way that happens. So we use your bottom number, and the how many ways goes in the bottom number. There's only one way that they're set up in chair, secretary, webmaster. So we set it over your denominator. So be careful when they ask how many ways, when they ask probabilities. You always have to have how many ways anyway. You have to find those first. Okay, so you guys are now going to try this one. permutations first of all. Combinations? Who said combinations? What?
Oh, because it's eggs.
Okay, so what are we looking for? We want it to serve as what though?
No.
No order? What did they ask for? Two members to serve as what? Sports chair and secretary. So if I pick two people, if I pick you and Julia, does it matter who I assign secretary and who I assign? You want to be the secretary, I will let her be the chair?
Because they're both equally serving.
Right, every member has an equal chance. Every member has an equal chance out of the 20 to be selected to be a chair or a secretary. So is there a difference if I make you chair and Julia secretary, or Julia chair and you secretary?
Yes.
So therefore, order matters, right? So permutations, find your ways first. 20, and how many do you want? 2. So how many ways does this give us? 380, good. And there's only one way that I can choose that exact pair of chair and...
So the pair goes together, it's not like one after the other?
No, what they're asking is this. There's a 380 different ways to set up Julia and Mike, Mike and Julia, Carly and Julia, Julia and Carly. I keep going with this. There's 380 ways. But my president and my vice president are Sarah and Ariel. How many different ways out of this whole group am I going to pick Sarah and Ariel? One way. 1 out of 380. I'm only going to pick them one way. I can lay out all my groups, but my real chair and my secretary are Sarah and Ariel. There's only one of those in here. There's an Ariel and a Sarah and Ariel, but there's, out of the 380 ways, there's only one way that can happen. That's what they're asking. I think their goal here was to talk about ways versus probability, which is why they did the 1 out of first, just so that you see the difference between ways and probability. Because one of the biggest things that I find with kids when it's difficult enough to figure out my permutations and my combinations. But then they always ask, what is the probability? To do the probability, you still have to figure out how many ways it happens. And then you have to use it in a probability. So I think that's their point in doing it this way. They always say you're equally likely, because if it's not, then it's biased. Okay. Find the probability of being dealt 5 diamonds in a deck of 52 playing cards. Does it matter what order you hold those diamonds in, or does it matter which diamonds I give you?
No.
No. So if order, that's your first thing you decide. Does order matter in my diamonds?
No.
No. So if order doesn't matter, I'm using a combination. That's how you start. So how many cards do I have to choose from? 52. Okay, here, let's take this apart. 52 cards. How many of these are diamonds? So how many? Find the probability. We've got something over the whole, part over the whole. This relates to all my possibilities. This relates to just my diamonds. This is actually a really good question to see this probability. So the first thing I want to do, I always call this all my possibilities, the generic part. Any 5 cards. What is the probability of choosing any 5 cards? That's going to go in my generic part. By how many ways can I choose 5 cards? So in your calculator, how many ways can you choose 5 cards? Could you just read me those? Just let me yell out the numbers.
2, 5, 9, 8, 9, 6, 0.
Thank you. Okay, so we've got a lot of different ways to choose those numbers. Out of those possibilities of choosing any 5 cards, I want this specific case, just diamonds. So how many diamonds do I get to choose from? 13, and how many of those do I want? 5. So the probability of whichever 5 diamonds I get, and I don't care what order they sit in, give me that top number, if you will,
3,287.
over this number. Now, you can put this whole thing in your calculator at the same time. The whole thing can go in your calculator at the same time. And you can put this in as a combination like this. So try this for a minute. Try and put that in your calculator and let me look at it. Again, when you're finding your probability, you always have to find out how many ways first you can do this. That's your bottom number. So in this case, how many ways is any 5 cards? Give me any 5 cards. So how many different combinations of choosing any 5 cards? Out of those, what's my probability that I will get 4 of those 4 diamonds in a row? 5 diamonds. So how many diamonds do I have in my deck? That's my top card. My probability of what I want over all my endless probabilities, so the ones on the bottom. So you guys try the next one. Try it yourself. 7. Okay, so let's see what you come up with. We want the probability of being dealt 5 diamonds from your standard deck. However, this time we're putting the 2 jokers into your deck. So first off, if we put the 2 jokers into your deck, how many cards will your deck have now? 54 cards. In this case, the jokers, both of them, are considered to, well, the joker is a wild card. You have 2 wild cards. And it can be used to represent any card in the deck. So if you want the probability of being dealt 5 diamonds and you just added 2 more cards in there, so that it works in your favor, what are you going to make them represent? Diamonds. They're going to be diamonds. So now, how many diamonds will you have in your deck? 15. You had your 13 plus your 2. Why add 2 more cards and not be in your advantage? If you add 2 more cards and you don't make them represent diamonds, you make your probability harder. So, probability that we get 5 diamonds dealt from my deck with my jokers. Does order matter which way we hold the diamonds? So right away I know I'm going to use a combination. Probability says I need a top and a bottom. I need how many ways here? The bottom is your generic one. Any 5. I want any 5 from how many cards? 54. So the top says I want 5 diamonds from how many diamonds? 15. Okay? So try to put that in your calculator. If you were ready, put the other one in. A nice way to do it, if mine's still in there, just pull it down, second enter, and just go back and change this. Change this to 54, and change this to 15. So how do I write this as a decimal? 0.0009. My probability improved a little bit from my 0.0005. Yes? Okay. All right. So don't forget, probabilities, you need a bottom number. Okay. A little bit different one. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. From this particular sample, they found 3 corn kernels have high levels of toxin. Therefore, from this 400, if 3 are toxic, how many are not toxic? Three are toxic from my 400. 397. Always start like this. Not toxic. Altogether, you have 4 corn kernels. 4 kernels are selected at random from the sample. Does it matter what order I pull these kernels in? No. What is the probability that I get exactly 1 toxic kernel? First of all, well, let's take another step back. What is the probability that I get 4 toxic kernels? What's the probability that all 4 are toxic? 0. Why? There's only 3. There's only 3 toxic. So I can't find all 4. So I got to start this. I have, and you told me I have combinations. And I have a probability. So I start like this. As soon as I see probability, I start like this. The bottom is my generic. How many do I want to choose? 4. From how many? 400. Any 4. Like, how many ways can I choose groups of 4? Then I want to know particularly how many ways will that group contain 1 toxic. I need 1 toxic, 3 non-toxic. So how many toxics are there in this? There's 3. And how many of them do I want? I want 1 times. How many non-toxics are there? And how many of those do I want? 3. There's your combination statement. Your rule says, what was that rule? I just lost it in my head. You're going to multiply the top and divide it by the bottom. Now, you can put it in your calculator just like that because order of operations will multiply these and then we'll divide by that. So try it. Put it in your calculator. You got to be able to come up with an answer. You can, of course, do the numerator and then you can do the bottom. Your counting principle says to multiply the tops. I find the easiest way is to walk these through one step at a time. Probability, draw a line. You need a top and a bottom. A numerator or denominator. Denominator is my generic thing. Any 3, any 4, any 5, any of the cards, any of the kernels. The top part is exactly what I want. And write this out. This makes life easier if you write this out. So what did we come up with?
0.03.
Okay, 0.03. Good. So you have a 3% chance of choosing 4 kernels from this group of 400 and have one of them be toxic. Okay? Make sense? All right. All right. Where's my try at 7? Well, I guess we don't. Well, here's a try at 8. Let's talk this one. A jury consists of 5 men and 7 women. So put them out here. 5 men, 7 women. How many people sit on your jury? So, good. 3 jury members are selected at random for an interview. Does it matter what order it said? Does it care what order I select them in? So right away I know I have a combination. And I'm looking for a probability. Right away I know I have this situation. Numerator, denominator. I want the probability that all 3 are men. Out of how many? How many am I choosing? 3. I want the probability that I choose 3 men out of all the jurors. So first of all, bottom number. What's my bottom number going to be? It's a combination on both sides. What's my bottom number? My generic. 12. C. How many do I want to choose? 3. Okay? Bottom number, any three. How many groups of three can I make? Of those, how many are going to be three men? So, how many men do I have to choose from? 5. I want 3 of them. Can you see this happening? Okay, and you can put that in your calculator and compute that. Come out to be 4, 5. Good? Questions at all? You have a test on Friday. Make sure this homework is done by tomorrow.